Hi guys, how y'all doing? It's kind of a weird situation we're in, but this is the way it's going to be for a little bit. So it's not too much different than being in class. You're just not around your peers, but you still see my paper and my beautiful hand. And I hope you guys are doing well, and I hope you had a good break. And hopefully we'll get to see each other soon. I miss you guys. Um, if you remember, back before spring break, we finished chapter 9, so we're going to start with chapter 10, which is all about area. Um, a lot about area, anyway. This section, not so much. But it's not too difficult of a chapter. You'll see a lot of this chapter at home. Hopefully, um, we'll be back and you can finish it up and take the test at school. Um, so anyway, today's section is about the angle measures of polygons and regular polygon tessellation. So first thing we're going to do is we're going to see if we can find a relationship between a polygon's number of sides and the sum of the interior angles. Okay, so normally, if we were in class, I'd say, well, why don't you try and figure it out? And then um, it would be kind of difficult. But, since I can't really interact with you right now, um, I'll just kind of show you how to do it. So you know what a triangle's interior angles are. It's 180, right? And you should remember what a quadrilateral is. It's 360, but if you don't remember that, how do you figure that out? Well, you draw a diagonal. And if you draw a diagonal, what do you have? Well, you have two triangles. So this is 180, and this triangle also has 180 degrees for interior angles. That means a total of 360. No, not a total of 180. And then you do the same with the other. So from a single vertex, you draw all the diagonals you can. And a five-sided figure would make three triangles. So this one has 180 degrees in that triangle. That triangle has 180 degrees. And the third triangle has 180 degrees. So if you put all of those together, you got 540 degrees. And then with a hexagon, a six-sided figure, again, you pick a vertex and you draw all the diagonals from that vertex. And you've got four triangles. And again, each triangle has 180 degrees. If you put all of those 180s together, you got 720. So hopefully by now, you would figure, well, what's happening here? 180 to 360, 360 to 540, 540 to 720. We'll look at each of the figures. We're adding a triangle each time, so that means we're adding 180 degrees each time. So that means a seven-sided figure, you would add 180, would have 900 degrees, and an eight-sided figure would have 1080, and so on and so forth. So what you can do is you can generalize that. You can say, well, how can I figure out how many triangles there are? Well, if there's three sides, there's one triangle. If there's four sides, there's two. If there's five, there's three triangles. If there's six sides, there are four triangles. So what is the relationship between the sides and the number of triangles? So six had four, five had three, four had two, three had one. So it's the number of sides minus two, and then that tells you how many triangles you have. So then however many triangles you have, you multiply by 180. And that's the formula. And normally I write it this way. It's weird to have the 180 in the back. So it's the number of sides minus 2 times 180. And that's the way I usually write that formula. So that will find the measure of the sum of the interior angles of any convex polygon. So this wouldn't work for a concave polygon. Remember, concave has kind of a hole in it. Like that, but it works for convex polygons. So it's the number of sides minus 2 times 180, and that is the sum of the measures of the interior angles of any convex polygon. So that's a pretty good formula, not too hard to remember, and easy to apply as well. So it says find the number of the measures of the interior angles of an octagon. So I already kind of told you that above, but an octagon has 8 sides. So you plug it into the formula, 180 times 8 minus 2. PEMDAS would say do your parentheses first. So you've got 180 times 6. And 180 times 6 is 1080, 1080 degrees. So if you add up all the interior angles of any convex octagon, it's going to be 1080 degrees, 1080. A dodecagon. Remember, do means 2, deca means 10, so 2 and 10. That's a 12-sided figure. So we plug it into the formula. 180 times 12 minus 2. 180 times 10. 1,800. So any 12-sided convex polygon is going to add up all of the interior angles. Each of the interior angles, like down here, these are interior angles inside of the polygon. It would add up to 1,800 every time. It's interesting. Next one is find the value of x. So this is going to take it one step further. What does x have to be in order for this polygon to work? So the first thing you're going to want to do is want to know, what do all of the angles have to add up to equal? So you do that by looking at, well, how many sides are there? 1, 2, 3, 4, 5, 6. So a 6-sided figure. So this thing has 6 sides. Okay, so if I plug that into my formula, 180 times 4, because 6 minus 2 is 4, or you can look above. Any 6-sided figure has to be 720. So I know when I add all of these angles up, it's got to equal 720. And then I'm just going to go around and add up each of these, right? So remember, this is 90 here. Don't forget about those, even though they're not really labeled. 90 there. So let's see. If I add up, well, I'll just start with my x's. I have an x there, and I have an x there. So I have 2x. And I've got plus. Now I've got all of these to add up. So let's see. 90 and 90 is 180. 180 and 20 is 200. 200 and 125 is 325. And 325 plus 135 is 460. And if I made a mistake, just write down the right number in your notes. But I think I got it right. So I have 2x plus 460. That is the sum of all of these interior angles. It has to equal 720 because it's a 6-sided figure. And then it's nice and easy to solve. You've been solving algebra problems like this for quite a while. Subtract 460 and you get 220. That's not right. 260. Oh my goodness. It's been a spring break for me too. Let me just check. Now I feel like I didn't do it right. 720 minus 460. 260. Okay, I did do it right. 2x equals 260. And divide by 2, and x equals 130. So x is 130. That's all they ask us to find. Find the value of x. All right, you can try the next one if you want on your own by pausing the video. Otherwise, I will do it too. And you can check your work if you did pause it. So again, the first thing you want to determine is how many sides are there? 1, 2, 3, 4, 5. 5 sides. So you plug it in the formula. 180 times 5 minus 2. That's 180 times 3. 180 times 3 is 540. So I know when I add up all of these angles, it has to equal 540. So I know it's going to equal 540. Now I just have to actually physically add up all of these numbers. I'm going to fill in that 90 there just so I don't forget it. Okay, so first thing I look at are my x's. I've got 2x, and I've got 1x. I've got a total of 3 x's. And then don't forget, when I do add those normal numbers, that is a minus 20 this time. So that's going to make it just pay attention to that. So I've got 90 and 110, which is 200. 200 and 135 is 335. 335 minus 20 is 315. So we've got 3x plus 315 equals 540. Of course, subtract 315 from both sides, and you're left with 225. So if 3x equals 225, you divide by 3, and x would equal 75. And again, they just asked us to find x. They didn't say what is angle in or anything like that. If they did, you know what to do. You just plug it in. No big deal. Okay. Let's see, the next one. So this is going to take our formula and just, apply a couple more things to it. Find the measure of one interior angle in a regular hexagon. So you have to remember what regular means. Regular means all angles are the same. And all sides are the same also, but it doesn't really matter. We're just concerned about the angles because we're finding one of the interior angles. Okay, so in a regular hexagon, we already know, according to our formula, that n minus 2 times 180, number of sides minus 2 times 180, 6 minus 2 times 180, 4 times 180. All of these angles have to be 720. Well, if all of those angles are the same, there are 1, 2, 3, 4, 5, 6 angles, right? So if all of them are the same, and all of them have to add up to 720, how do I find just one? Well, clearly we would do 720 divided by 6. And that means one angle is going to be 120 degrees. So a single angle in any regular hexagon is 120 degrees. Sorry, that one's a little mushed. So think about that. What formula did we do? Well, we did the n 180 times n minus 2 divided by, what did we divide by? We divided by 6. What is 6? The number of sides. So it's divided by n. So that's another formula you can remember if you want. And that will find, we can apply it to this one, a pentagon. So we just plug in 5 for both of those ends. So it would be 180 times 5 minus 2 divided by 5, right? And then you just work through the math, or you can draw the picture, whichever you prefer. Okay. But that formula is going to be really helpful for these next two examples. So if I do the math, that would be 180 times 3 divided by 5. 180 times 3 is 540, and 540 divided by 5 is 108. So in any pentagon, any regular pentagon, the angles are 108 degrees. So you can draw 108 degrees 5 times and you got yourself a pentagon. Okay, so again, this formula right here is going to be really helpful for these two problems. It says the measure of a single interior angle of some regular polygon is 144 degrees. We want to know, what is the number of sides of that polygon? So we're going to start with this formula. 180 times n minus 2 divided by n equals, what does it equal? So this formula tells us what a single angle is, right? So they tell us a single angle is 144. So we can take that formula and set it equal to 144. And you look at that and you're like, oh man, that's not that great to solve, but it's really not that hard either. Remember, if there's a fraction in your problem, the first thing you want to do is multiply the whole thing by the common denominator, which is n. So those n's would cancel each other out, and that would leave you with the 180 times n minus 2 equal to, and then we've got n times 144, that's 144n. So I didn't give you quite enough room on this one. I should have written a little smaller, given you a little more room. So then we've got a nice, easy equation to solve. You distribute that 180, and you have 180n minus 360 equals 144n. And then I would probably subtract 144n from both sides. And then at the same time, I would probably go ahead and add 360 to both sides. I like, positive numbers, but if you wanted, you could have subtracted 180 and done one less step. So those two things cancel, those two things cancel. And then 180n minus 144n is 36n. And then equals, the only thing left on the right side, 360. 36n equals 360, then n has to equal, of course, 10. So the number of sides would have 10. So what kind of polygon is it? It's a decagon, right? Okay. So if you want, try this one, pause the video and try that one, see if you can do it. Again, use the same formula, set it equal to whatever number they give you. Again, that works with a regular polygon. So let's do this one together, or pause it and then compare. So let's see, 180 times n minus 2 divided by the number of sides has to equal 140. So it's going to follow the same steps. First thing, multiply by the common denominator to get rid of those fractions. So you're going to be left with those n's cancel, 180n. I'm going to go ahead and distribute, minus 360. Notice that's always going to be the same, 180n minus 360, 180n minus 360 equals 140n. All right, this time I will just move the 180n by subtracting 180n from both sides of the equation. Those cancel, and we've got negative 360 equals negative 40n. If you divide by negative 40, what does n equal? N equals 9. So how many sides does it have? 9. What type of figure is it? A nonagon. Yeah. Maybe you remember that. Okay. So that's angle measures. How fun is that? Now, on the back, we're going to be looking at exterior angles. Exterior angles. So those are the angles on the outside of a triangle, or of a figure. So an exterior angle, you're going to kind of continue one line around. So, if you imagine, like, remember how you fold those boxes and like seals itself, where you do like one side at a time and you go around it? That's kind of like exterior angles. So you continue around, continue, and then, so you can only have one exterior angle at a single vertex. You wouldn't continue both of them. That doesn't work. But then, so look at these exterior angles. A triangle, they took the exterior angles, they added them together and got 360. A four-sided figure, a quadrilateral, they took the exterior angles of just some random four-sided figure and they got 360. A pentagon, a random pentagon with weird angles inside of it. They made the exterior angles and they add up to 360. So amazingly, the sum is 360 each time. So that is always going to be true. So you take the exterior angles of any polygon, any convex polygon, and it's going to add up to equal 360. And remember, how do you find the exterior angle? What do the straight line have to be? It's got to be 180, 180, 180, 180, 180. So if you have the interior angle, the exterior angle is the other part of the linear pair, the other part of 180. Okay. So find the measure of each exterior angle of a regular pentagon. Okay, so regular is a big key. All of them have to be the same. What do all of the exterior angles have to add up to equal? Remember, for any figure, the exterior angles have to be 360. So to find a single angle, if all of them add up to 360, to find a single one, all we have to do is 360 divided by 5. And that would be 72. All of these angles are 72 degrees. Because each of them are the same, and they all have to add up to 360 together. 72 times 5 is 360. And similarly, if you had a 15-gon, a regular 15-gon, all of them again have to add up to 360. The exterior angle is divided by 15. And what is that? 24 degrees, I believe. Each exterior angle is 24 degrees. Okay, so that's a simple application. This one's a little tougher, not much. Find the value of x, then find each exterior angle measure. So a little bit of work here. So again, I've got a convex polygon. It's a five-sided figure, a convex pentagon. I know that if I take all of these exterior angles, they have to add up to equal 360, because any exterior angles of any polygon adds up to 360. So add them up. 5x, 1x, 2x, 2x, and 4x. Let's see, 5 and 1 is 6, plus 2 is 8, plus 2 is 10. So 14x, and then 7 and 3 makes 10. So 14x plus 10 equals 360. Subtract 10, and 14x equals 350. Divide, and 350 divided by 14 equals 25. X is 25. Now remember, they don't ask us just to find x, they say find each angle. So we'll go ahead and plug that in. So this one, 5 times 25 is 125, plus 3 is 128. That one's just x, so it's 25. These two are both 2 times x, so they're 50. And this one's 4 times x, which is 100, plus 7, 107. If you take all of those, they should add up to 360. That's how you can check your work and see if you did it correctly. This one looks like we got ourselves a kite, because these angles are the same, but doesn't really matter. Again, take the exterior angles, set it equal to 360. If you want to try that one on your own, you can. Add up all x terms, x plus x plus x plus 2x. There's 5 x's there. Got a negative 11 and a negative 4, that's a negative 15. So you'd add 15, and 5x equals 375. Divide by 5. You've got 75. X is 75. Plug it in, and these angles, of course, are 75 each. 75 minus 4 is 71, and 2 times 75 is 150. 150 minus 11 is 139. Do those add up to 360? Yes, they do. So there you go. Simple, simple. The last thing, just a quick note, a tessellation or tiling is a repeating pattern of figures that completely covers a plane without gaps or overlaps. Good examples of tessellations include honeycombs and tiled floors or walls. So all of that means a tessellation is a repeating of some shape or some sum of shapes, like multiple shapes, as long as there's no gaps or overlaps. So tiling is a good example. Honeycombs and a beehive are a good example. Look around at your kitchen backsplash or the tiles in your bathroom. That is tessellation, because the tiles can't have a gap in them and they can't overlap, or else the floor wouldn't work. So how do you know? So a lot of questions you're going to be asked is, does this figure tessellate? Does this figure tessellate? So would it make a pattern with no gaps or overlaps? And to figure that out, you take the angle, and if the angle divides 360, so if 360 is divisible by whatever angle of the type of figure is, if it divides 360, then yes, it would tessellate. So that's why this is for regular figures, by the way. If you had a rectangle, it tessellates because its angle is 90, and 360 is divisible by 90, it equals 4. It comes out even. If it doesn't come out even, it doesn't tessellate. So that's one type of problem you'll see. Another one is, do these figures together tessellate? So you'd add up the interior angles of each figure separately and see if it adds up to 360. I hope that answers your questions. If you do have questions, I'm available to meet with you. I'm going to be using Google Hangouts, or you can email me so we can do videos, video chat, and I can work through problems with you. You can see my document camera like you would at school, and I can show you what I'm doing, and hopefully you can get all your questions answered. Just reach out, please. Don't be afraid to. And again, I miss you guys. Hopefully, I'll hear from you soon. Even if you don't have a question, if you just want to say, hey, do that. That'd be cool. All right, I'll talk to you later. Let me know if you have any questions. I'm available for you. Bye.